All right, last year at Sage EduDays, we invited Michael Pearson, who at that time was program director at the MAA, and he was mostly there to observe and work with some of the web work people and get to know Sage. But he managed to write and interact during the 2 days that he was there, so we had him get up and present his interact. I think we're going to start instituting a most improved award, just like your child's youth soccer team. So I think from my observations, most improved, and there may be somebody who's done more, but I was working with Gwyn a little bit yesterday on some interact stuff, so I think we're going to give Gwyn the most improved award, and therefore she has to speak. So show us what
her acceptance speech. Yeah.
I'm flattered, kind of. So a lot of what I've been working on is, again, I'm trying to mimic a lot of functionality that we had in MathCAD for Sage. And in some ways that feels horrible to say because MathCAD is an awful, awful software that I would never recommend someone use. But a lot of the reasons that we've enjoyed it is the students, they can insert a graph easily, they can plot data easily, they can change how it looks sort of easily. A lot of the things that I know my department chair would like us to continue to be able to do is to have the students type in, create plot, and have some sort of box pop up where the students can select options. So one of the big things that I was looking to do is I didn't really know how to do things like how do you handle importing a CSV file and pull data out of it. So I spent most of my first day sort of learning how to process data of different types. And the main type of data that I spent the bulk of this doing is, as I mentioned on the first day, we actually have the students do a lab where they collect data from a temperature probe. And so they do 4 different sets of experiments where they're plunging a temperature probe into boiling hot water and looking to see how the temperature changes as the boiling water cools. There's another one where after they remove it from the hot water and watch it warm back up to room temperature, what happens, ice cold water, pulling it in and out. So they collect these 4 sets of cooling data, and then they're looking to fit a model to them via the Newton's law of cooling type arguments. So I'll come back to the interacts that I wrote, but you can see what they'll look like here. What the students will do is they'll actually go to Logger Pro and export their data as a CSV file, load that data up into this worksheet, and this actually has a lot of the, this is a, it's a reworked copy of the previous worksheet we had, where it explains Newton's law of cooling, we're finding solutions to a fixed differential equation, and we're going to model data, and there's an explanation now in Sage of how to import this data that they've collected. One of the things that I did write as well, another mini interact, is rather than having the students learn the commands for, okay, how do I access using the OS imported libraries, how do I access the file, and so essentially one of the now behind the scenes interacts that I've written is the data drop down. So what this will actually do is it produces a little box, and there aren't that many data sets in this one, so it's not that interesting, but I have 2 different data sets that all the students have to do is select one. And so this, again, this is actually a function calling an interact that does all this. This interact actually exports 2 global variables named data, which is just the raw data that's the scatter plot, and axis labels, which is the list of what exactly these pieces of data were. So as soon as the student clicks on one of these, let's say hot water temperatures, the student now has access to these 2 variables without having to really understand how the file structures are working in this. So if I wanted to actually look at these, again, each of these data, like all it actually exported that data as a variable where there's just a list of pairs. It exported the variable axis labels as time and temperature were the 2 things that Logger Pro sent over. So this is useful for me in that now I can actually, at the top of a lot of the worksheets I've been developing, I have something similar where whatever data files have been attached to whatever data sets I'd like them to model, they're stored as CSV files, and the students can just grab those data sets and set them to whatever variables they'd like. What's up?
You can put %auto at the top, and it'll automatically execute.
I have that in the.
Oh, okay.
I actually it automatically runs the functions at the start of this, but because they're importing their data sets, I didn't want them to have a little blue error message at the start. But yeah, I've been using the %auto and the %hide. Okay, champ. So the actual code, is all up here at the top. And so I think since the current server the students have been using, I might actually just add these functions somewhere rather than having them at the top of every rather than the top of every worksheet. But for now, since I'm still trying to figure out what functions we would like, they're going to be living in the worksheets individually for a bit. But again, this is, I really like that you can call interacts as functions, because then it's a lot easier for me to make up some nice things for the students that are short, easy for them to remember. And again, at least at the very start of playing with these, this is within the first 3 labs that they've done. And I guess I should have started with this. Our calculus course is very laboratory based. We meet with the students 6 hours a week, every week from the start of the semester to the end. So with 6 hours, we have a little bit of flexibility whether we're in the computer lab or whether we're actually doing more traditional lectures or in-class worksheets. But as a result, my students by the end of the semester have done something somewhere between 12 to 20 labs, depending on that semester. So it's a very computer-intensive course where we've done most of our work in MathCAD, and I personally am kind of glad that I can stop lying to the students a little and being like, of course you'll use MathCAD later. Whereas easily, if they're going to grad school or if they're going to work in the industry, Sage seems like the type of software that I can say without any prevaricating is a much more useful skill. If nothing else, they'll be learning programming in Python, which I feel like as interpreted languages go, is not so bad. So this was one of the interacts that I wrote. I have a couple variations on this in later worksheets, but this is also what I needed. One of the things I got out of this is I actually didn't know the HTML table function existed. So I've been writing these little tables for them that just, it's essentially was a print command, but having the HTML table is kind of nice, but you can see sort of a short excerpt of what their data looks like. That's we wanted to have, what's up?
How are you doing the header? So you can pass a list to the header, you don't have to just say true. You can pass the actual header to the header parameter.
Oh, okay. So, okay,
Which makes
this
it
was
a little bit simpler.
I was a little concerned, like having the students read it, so the header would actually just be presumably these axis labels then.
So you can say header equals axis labels.
All right.
So sorry, do you mind if we just
No,
cut
that
out
sounds-
things that might help?
Oops.
So you got a missing parenthesis after data.
Ah, there we go.
You don't need the parenthesis there. There you go. Yeah.
All right.
That's easy.
Good to know.
Easier.
That's actually much. I was a little So
Right.
that's great. So thank you for the suggestions. So I have them learn how to pull data. They don't even know how to. The students that come in don't know the idea of calling elements from lists is new to them. So I've got a couple of small commands. This is still again relatively early, so they're not entirely comfortable. But the other interact that so there are actually 2 more interacts, but this is one of them is this decorated plot, which is probably not going to be the final name of this function, but it was simple and didn't conflict with anything that was already there. So this is an interact that gives them the option of inputting a graph title, their X and Y axis labels, X and Y, so these are the labels on the axis. So right now it just reads insert units. It allows them to choose their label, which among other things, I'd like to gradually wean them away from using a drop-down box so the drop-down menu says what the actual marker label they're going to use is. So if I wanted hexagons, and unfortunately my mouse is a little fuzzy, so this may or may not be great with that. Blue hexagons. Actually, it looks like it was
Just see
blue
the
outline
color.
hexagons.
Base color, yeah.
So I was messing with this earlier, so I guess they can change the sizing. So this is I guess this is the hot water cooling graph. And we have them one of the reasons I did want these to look relatively nice with labels is we have our students write lab reports for almost every lab they do. So we'd like them to have a graphic that they can export easily that has appropriate labels. So I guess the X units are going to be time in seconds. Actually, this particular one, I think it's time in minutes, and the Y units are going to be temperature in degrees Celsius. So now my students have a graphic that they can nicely. What's up?
How are they writing the lab reports? Are they putting it in are they right-clicking and saving and then putting it in a Word document?
Exactly.
Okay.
So, I kind of was I was going to ask you about whether there was a function that there could be an export graphic to something that I could
Right,
put in
but
an
it's
interact.
just an image in the
Yeah,
browser.
exactly. So they can just save it directly. So a couple
You
of
can drag it
nice.
onto your desktop.
Yeah, I didn't that's not sort of the end of the world complicated. So this is precisely what I wanted. There's a couple more things. Let's say for the hot water cooling, I think I forget what the ambient temperature is. I can probably go up and see it. Let's say it's around 26, or like I actually have them search through the data and calculate this, shift their data. They actually go through and they model this whole thing, so I don't need to actually look at another graph of exactly the same thing shifted down, but so the last function that it's another interact, that they actually are, so this decorated plot with function is not particularly general. But this is actually another interact where now the graph comes up and they actually are fitting an exponential model that they can see the equation of what they're fitting with sliders. And so they're not supposed to do this lab by just sitting there and fiddling with the A and the K per se, but once they have solved for a potential A and K, they can easily check. And so I think I put the sliders down at the bottom to make them a little easier to see. But for this one, I think A was somewhere around 35 and K was somewhere around like 3, but I'm not going to worry too much about the particular fit. So they're supposed to solve and then check appropriate fit for these things later. And after, I'm going to speak with the other instructors and see whether they prefer slider bars or input boxes and sort of what their ideal input format for the students is. But so far I like this. And these functions, again, in the other laboratories that I'm sort of gradually modeling, we do a lot of, the students have a given set of data, they plot it, and they fit a model. And so again, I would like to, eventually, the students should be able to take a given data set that's given as ordered pairs and just use scatter plot and show. But at the very start, the students are going to be bamboozled by even just logging into software, so I wanted to handhold them at least through the first couple of labs. So these, again, this functions that produce interacts for me at least are fairly useful. I'm really interested in trying out some of these in Sage server, the Sage cell server, after you mentioned that a lot of the problems I was running into about writing these functions is something that could take, let's say, a decorated plotter function that allows you to change the symbols and the marker sizes of, let's say, 10 different data sets or something that they're plotting simultaneously. Right now, that's very hard to do, just in this. So I don't know, back to the decorated plots. It's hard to have them compare different data plots using one of these little interacts, but in the Sage cell server, in theory, there's something that would allow us to do that as well. And I think it'll be up in the air whether we're going to be using like a web page made with Sage cell servers in it, and then have them writing up a lot of their work as they go, or whether they're going to be writing this out and printing out a copy of the worksheet. It really, again, we're in transition, so the format's up in the air. But this was very nice. I really, again, these interact boxes can be quite fun. I think the other thing I'd like to, for this particular one, is an animate that actually adjusts a lot of these parameters for them, so it'll sit there and adjust. But I don't know. That's about it. This is fairly light. Again, a lot of the things that we're mocking up. Apparently, my connection to my virtual box that I was looking at these labs in is collapsed, but the labs that we're mocking up are quite nice, and they parallel the Duke modeling and application calculus textbook. But again, in MathCAD, there's only really so enjoyable they can be. So I'm looking forward to this. And I guess that's about it. This was a few examples.
Any questions or comments for Gwyn? Okay, that was great. We'll have one more talk. Just